Okay, now we've got these quadratic functions, but they are inequalities. And remember, with inequalities, it's the shading. So you still have to look for either dashed lines and hollow dots or solid lines and solid dots. So if the inequality sign is greater than or equal or less than equal, solid lines, solid dots. If the inequality sign is greater than or less than, dashed lines and hollow dots. Number 4 here is already in vertex form, so that makes it pretty easy. So you're going to go ahead and take the additive inverse to -3, which is +3. You're going to take this one exactly, and it would maybe help you to do a table of values. That usually is pretty helpful. So we said +3 and then exactly -2. So 3, -2. Oh, this is going to be a hollow dot though. Oops, sorry. Hollow dot. And then we just go 2 numbers to the left, 2 numbers to the right. And since this is subtract, I'm going to use 4 and 5. Normally I would use 1 and 2, but I'm going to use 4 and 5. So if I put 4 in there, 4 subtract 1 is 1. 1 squared is 1. 2 times 1 is 1. 2 subtract 2 is 0. Those two will have the same height. So 2, whoops, hollow dot, I need to stay focused. And then 5, we put 5 in there. 5 subtract 3 is 2. 2 squared is 4. 2 times 4 is 8. 8 subtract 2 is 6. So at 5 we're up at 6, hollow dot, and at 1 we're up at 6, hollow dot. And then, so I'm going to have to make that a little bit thicker so you know what I'm doing. All right, because we're going to have to imagine that if we put 0 in there, we'd get -3 squared, which is 9. 9 times 2 is 18. 18 subtract 2 is 16. So way up here at 16, this graph is going to be doing this. Let me make this a little bit. And it's going to be a dashed line. And then remember what we said about shading. And yes, one of the methods is to take 2 points. So you take one point inside the parabola, 1 point on the outside of the parabola, and check to see which one makes that true. The other way that I've shown you is you pay attention to this. It says y's are all the y's greater. So right here on the y-axis, right up there at 16, remember this is a dashed line that's doing this. So when we go greater than 16, notice that falls inside, so you shade everywhere on the inside of the parabola. And that's the answer. The shaded part is the answer. Okay, so let's come over to this one. This one, you would have to do a table of values. What I notice is, before we factor that, -2, -16, -30 all have a -2 in common. So that's going to factor 2. If we factor out a -2, -16 divided -2 is +8x. And -30 divided -2 is +15. Now, factors of 15 that add up to 8, that would be 3 and 5. So now this x will equal -3. This x will equal -5. Oh, also dashed line, hollow dot, because of this inequality sign. So -3 and -5. So that means 4 at -4. So we can do that. Let's see. So if we put negative 4 in here, negative 4 plus 3 is negative 1. Negative 4 plus 5 is 1. Negative 1 times positive 1 is negative 1. Negative 1 times negative 1 times negative 2 is 2. So this graph is going to be doing this, and all the way down here at negative 30, so I'm going to put a hollow dot all the way down here at negative 30. I'm going to erase this stuff now. You can go back and rewind if you need that back up there. So we're going to go all the way here. I'll put negative 30 right there. I didn't do that very well, but you kind of get the gist. And this is going to go like that. All right. So now, what does this inequality say? This says y are all the values greater than. So when you put your pencil right there on the y-axis and you go up, it's on the outside of that. So you shade everywhere on the outside of that inequality. If you don't like that method, you would just pick a point inside here. Let's say x is negative 4, y is 0. So y is 0, and we're going to put a negative 4 in there. Negative 2 times negative 4 squared. Well, negative 2, negative 4 squared is 16. That's negative 32. And when we put a negative 4 here, that's positive 64. Negative 32 plus positive 64 is 32. 32 subtract 30 is positive 2. Is 0 greater than positive 2? False. And notice we did not shade inside. So all of this stuff, we could try any one of these coordinate points and it will make that inequality true. All right, that's it for this one.